Welcome back to the channel. It's always a pleasure to have you here. Alright, so this is Pendulmatics and I'm Pendulum, your tutor on this channel. This still remains the complete online school of mathematics, and today we'll be concluding with simultaneous equations. We are still going to look at one linear, one quadratic simultaneous equations, but today we'll be looking at how to solve them using graphs. So how you can use graphical method to resolve one linear, one quadratic simultaneous equation. So if you're new to the channel, you're welcome. Please subscribe and turn on the notifications button, ring that notifications bell so that whenever we have new videos like this, you'll be notified to come and watch and learn. All right, so this is what we'll be looking at today, this question on the board. All right, so as we go on, please don't forget to drop a like on the video. Drop your thoughts as well in the comments. Let me know what you think about the video. If you have questions or whatever, just put it in the comments, and then share this video far and wide with your friends, your children, your words, wherever you can share it, on your status, on Facebook, on WhatsApp, on Telegram. All right, the more the merrier. Okay, so you're welcome. Let's begin quickly. Now the question says we should use a scale of 2 cm to 1 unit on the x-axis and 2 cm to 10 units on the y-axis to draw the graph of this for these values of x. So this is our quadratic equation, 2x squared minus 3x minus 7, and these are our values. So the first thing we need to do is to obviously get our table of value. Okay, so I think I'll do it up there, or should I do it here? Maybe I'll do it here because of space. Okay, let me just do it here. Let me do it here. Okay, so this is for y equals to 2x squared minus 3x minus 7. Now, of course, we have x. Okay, if you've watched our video on quadratic equation solving using graphs, then this will not be strange to you. So this is x, this will be 2x squared, this will be minus 3x minus 7. Okay, and then we'll have the last one, which will be y. Okay, so we have x and y at the extremes, x, y. Then these terms that make up the quadratic equation, we'll break it and distribute it within the table. So the first one is 2x squared minus 3x minus 7. So if this is a bit confusing, do well to go watch our video on how to solve quadratic equations using graph, okay, or using graphical method. Now our values of x are from minus 2 to 2. So we have minus 2, minus 1, 0, okay, 1 and 2. Alright, minus 2, minus 1, 0, 1 and 2. That is covering this range of values. Alright, now minus 7 is constant, so you're just going to run throughout the table. Minus 7, minus 7, minus 7. Now this is 2x squared. 2x squared means 2 times all these values of x squared. Alright, so let me just do it out for you here. So when x is minus 2, you have 2 minus 2 squared. Okay, for when x is minus 2. Minus 2 squared is 4. Minus 2 times minus 2 is 4. 4 times 2 will give you 8. Alright, then when x is minus 1, you're going to have something like this. Minus 1 squared, that is minus 1 times minus 1 is 1. 1 times 2 is 2. Of course, if this is 0, to give you 0. Then when x is 1, you have something like this. 1 squared is 1 times 2, 2. When x is 2, that's for this last one. 2 squared is 4 times 2, 8. Alright? So that's for that code, for that row. And then here we have minus 3x, so minus 3 times each value of x. Minus 3 times minus 2 if x is minus 2. Minus 3 times minus 2 will give you 6. Minus 3 times minus 1, 3. Alright, minus 3 times 0, 0. Minus 3 times 1, minus 3. Minus 3 times 2, minus 6. So to get our y values, we add up all this. We add up these three middle columns. So 8 plus 6 is 14, minus 7 is 7. 2 plus 3 is 5. 5 minus 7 minus 2. 0 plus 0, 0 minus 7 minus 7. 2 minus 3 is minus 1. Minus 1 minus 7 is minus 8. 8 minus 6 is 2. 2 minus 7 is minus 5. Alright, so these are our values. X. You can decide to bring out another table, but there's no need for that. We can plot our graph using this table. Okay. Then we also have B per se. We should draw the same graph. The line y is equals to 2x minus 1. So this is the quadratic part. This is the linear part. Alright. So we are going to also create a table of value for this. Alright. If you watched the other video, I said, okay, when we did simultaneous equation by graphical method, I said you can use x0, you find the value of y, put y0, find the value of x. Alright, but in this case, since we are already given a range of values for the quadratic, it makes sense that we use those same range of values to plot the line. It will be basically the same thing, but just for uniformity, let's use the same range of values. Alright, so this is our table for y is equals to 2x minus 1. Now we have x from minus 2 to plus 2. Alright, so let's just use the same range of values for uniformity's sake. Then we have 2x minus 1 and then y. Okay, so minus 1 is constant. 2x means 2 times each value of x here. So 2 times minus 2, minus 4. 2 times minus 1, minus 2. 2 times 0, 0. 2 times 1, 2. 2 times 2, 4. Then if we fill this up, we'll add up this 2 in the middle to get our y value. Please, when you're adding up, do not add up this x row. Please, you add up the two or three middle rows, or 4, depending on the what they call it, the degree of your equation. This is a linear equation, so the degree is 1, so you have only 2 terms. Now this one, you have 3 terms. You add up the 3 in the middle. If you have 4 terms, you add up the 4 in the middle, but do not add the x value. Alright, so minus 4 minus 1 is minus 5. Minus 2 minus 1 minus 3. 0 minus 1 minus 1. 2 minus 1, 1. 4 minus 1, 3. Alright, so this is our table. Remember that the scale we are asked to use is 2 cm to 1 unit on the x-axis. Okay, 2 cm to 1 unit on the x-axis and 2 cm to 10 units on the y-axis. Alright, so we're going to use this scale. Now our x values are balanced, minus 2 on the negative side, 2 on the positive side. Then we also look at our y values. We have positive 7 and negative 8. Alright, so basically our graph will be in the middle. So I'm going to have something like this. It's basically going to be in the middle. So these are x, y, minus y, minus x. Now on the x-axis, we are told 2 cm to 1 unit. So it should be something like this. 1, 2, 3. Minus 1, minus 2, minus 3. Then 2 cm to 10 units on the y-axis. Well, this scale is even quite big. Let me use 2 cm to 5 units. This scale is big because our highest value here is minus 8. So if I use 2 cm to 10 units, the graph will be very small. So let me use 5 units. So we have 1, 5, 10. This is even still too big. But work with it like this. But you know what? Alright, so let me use this. I want a graph that is big, that is wide enough. So that's why I'm changing the scale. This scale given to us is going to be quite compressed. So I ended up using 1 cm to 1 unit on the y-axis. Alright, I ended up using 1 cm. I want a graph that is expanded. Please, if this is an exam, work with the scale you are given. Alright, work with the scale you are given if it's an exam. So, but this is just an example and it's for teaching purpose. So I want a graph that will be big enough, not one that will be cramped, so that you can actually see what I'm doing. But for an exam situation, please work with what you are given. Alright, so let's plot. We'll plot this, then we'll plot that. Alright, now remember we're plotting x against y. So when x is minus 2, y is 7. When x is minus 2, y is 7. So they are going to meet okay, somewhere here. When x is minus 1, y is minus 2. When x is minus 1, y is minus 2. So this is minus 1, this is minus 2. Somewhere here. When x is 0, y is minus 7. That's this. Remember this minus y. When x is 1, y is minus 8. So this is 1 on x. This is minus 8 on y. We'll meet somewhere here. When x is 2, y is minus 5. This is minus 5. This is 2. We'll meet somewhere here. Okay. So Alright, so let me draw if I draw my curve, it will come somewhere like this. Okay, before I join it, let me plot this. When x is minus 2, y is minus 5 for this one. So minus 2, minus 5. That's this. Let me use this. Then when x is minus 1, y is minus 3. So that just comes a bit here. When x is 0, y is minus 1. So that's this. When x is 1, y is 1, 1, 1. So that's this. And when x is 2, y is 3. So that is this. Sorry. Alright, so if you look at this, if we join this, if I join, let me start with the line. Please use your ruler for this. So this is a straight line. And then for the quadratic equation, that will be a curve. So I'll join this once. You're supposed to use a French curve for this. So forgive me if mine is not so straight. Okay? Forgive me if mine is not so straight. Now, you can clearly see that this curve needs to come up more to be able to reach this line. So what this means is we have to extend this table, because this line is supposed to cut this curve at 2 points. That will give you the roots of the equation. Remember that this is one linear, one quadratic. So you're supposed to get 4 roots, 2x and 2y. The two places where this line cuts the curve, you trace it to x, trace it to y. Those are your two equations. So we have to extend this one a bit so that it comes up and we see exactly where it gets. Also, let me just add 3 and see. Let me just add 3. Let me just add 3 and see what we get. So 3 square is we have 2 times 3 square. Alright, 3 square is 9 times 2, 18. Okay, then if you put 3 here, minus 3 times 3 is minus 9. And then we still have minus 7 here. So 18 minus 9 is 9. 9 minus 7 minus 2. So this is minus 2 and 3. That's this. So that means it will still come up like this. Alright, so okay, so let's go on. Obviously, we can see that the graph, the line and the curve, they intersect here and here. Alright, now if you want your own to be more accurate, then you're still going to need to extend this table more. So probably maybe you need to get 4 and 5 so that you have more points. Okay, you can see that from here I just continued on that same trajectory to raise it up. But if you want it to be more precise, you will need to add more values for x on the positive side. Let's use this and we'll get our answers. Now this one is already, you can already see that it's already traced to y and traced to x. Then on this point, let us trace it to y. I don't know how straight my hand is, but and then we'll trace it down to x. Okay, so we can call this x1, y1, and this is x2, y2. So if we get these values, we have that our roots are, now for this one, this should be about 3.5, about 3.5 for x, about 3.5 for x, and then for y, I'll say about 7.3 or so, because this is 7, this is 8, half of it is about 7.5. So let me take that place as 7.3. Remember, all these are approximations. If you're using a graph sheet, then this will fall on a line and you can get the exact value. But this is a board, so there are no lines. So I'm approximating it to be 7.3. This for our x1, y1. Or on this side, we can see that our x value is on -1, right? This is where it falls. It's on -1. And our y value is on -3. So these ones are a bit clearer. This one is -3, this one is -1. It's clearer. So x2, y2. Alright, so these are the roots of this equation. Okay, so basically when you're given something like this, one linear, one quadratic, just create your tables, plot the curve, that's the quadratic part, and then plot the straight line graph. Create your table and plot the straight line graph. Alright, where the graph and the curve meet, you trace that the point up to x, then to y, trace to that point to x, and then to y. Those are your two solutions. Alright, so this is x1, y1, and x2, y2. So our values of x here are 3.5 and -1. Our values of y are 7.3 and -3. Alright, so that is how you solve one linear, one quadratic using graphical method. I hope this was not confusing. I hope it was clear. And you can try more questions on your own and see how you'll be able to solve them. I'm not giving you an assignment because this is the end of simultaneous equations, but you can look for questions on your own and solve if you feel like trying your hands at it. Alright, so thank you for being here. Don't forget to like the video, drop your thoughts in the comments, and share this video far and wide. Alright, share it to as many people that will need it. Also, subscribe to the channel if you're new so that you don't miss our next topic. We'll be going into indices, logarithms, and sorts, so you don't want to miss that. Alright, so subscribe, ring the notifications bell so that you don't miss the next video. Thank you so much. I'll see you soon. Keep studying.